Hello everyone, I'm Alex Chepurnoy, also known as Kushti, and in this talk I'm going to present you our ErgoHack 7 project, which is about exploring sidechains on Ergo, and this is joint work with Rosware, also known as Soysor. Alright, and we start with motivation. So in perspective, we can imagine that there will be a lot of transactions, a lot of load on the Ergo blockchain, and Ergo is utilizing all the probably non-controversial layer 1 scaling solutions possible for classic proof of work security with reliance on hash function properties but in addition to layer 1 solutions, we should always consider other methods of scaling, solutions to offload the Ergo blockchains. There are some known constructions from the space we can use on the Ergo blockchain, such as Lightning Network, Hydra, which is Cardano specific at the moment implementation of an idea of state channels evolution with federated signing of states. Then there are some Ergo specific AVL plus 3 based off-chain constructions such as Plasma, like off-chain bank described in a post on the Ergo forum. And in this talk I'm going to explore sidechains, and also with Ergo specific trustless two-way pegging, which is quite novel and unique for the whole cryptocurrency space, I guess. Alright, so what is a sidechain? In the first place, it's a blockchain, so it could be characterized with its consensus mechanism and also with transactional model, and usually sidechains to be launched in order to having some new features. And then as we are talking about sidechains, so there is some pegging mechanism by which coins are transferred from main chain to side chain and back at a fixed or otherwise deterministic exchange rate, which is the definition from the earliest positional sidechains white paper. Alright, and well, I'm going to skip talking about consensus and transactional model mostly in this talk, and well, let's talk about pegging. So currently pegging is mostly federated or done via delegated proof of stake in sidechains we have now in the wild, such as Liquid, which is a Bitcoin sidechain, or Loom network sidechains, which is about, well, a constellation of Ethereum application-specific sidechains. So it's not that good to have federated pegging security and well, there were already some issues in the wild. So then trustless pegging is definitely a goal, as it allows to reduce sidechain security to only consensus security. Right. Okay. And why do we need for sidechains? Closing the motivation section. So in the first place, as I already well told, it's about solving main chain scalability issues by moving transactions to sidechains, usually on a per application basis. So then there is a sidechain, for example, for a DEX, or sidechain for well, mixing, or sidechain for voting application, and so on. And also sidechains, well, since the very first sidechains white paper, are considered for experimenting with novel features without touching the main chain, where it's usually worth to have a stable environment. So this is true for well, all the well-established blockchains such as Bitcoin or Ergo. So what can we experiment with in sidechains? So, well, in the first place, with consensus. So, for example, we can try hybrid proof of work plus proof of stake consensus. We can run sidechain with mandatory privacy. So, well, having truly private sidechain. Well, we can test some new opcodes for the Ergo tree smart contracts language. We can play with support for some zero knowledge primitives and so on, so on. Alright, so well, with this motivation in mind, so what are our results we have achieved during the hackathon? So we developed contracts for trustless two-way pegging, and also formulating on the way well requirements to sidechain design. So what do we need to have in a sidechain in order to have trustless two-way pegging with the Ergo blockchain? So contracts, code, and white paper are available. No off-chain code or tests yet. No, well, really launched sidechain, and well, contracts and white paper are still raw, but we are polishing them slowly. Alright, so let's start with some assumptions we do need to make in order to have trustless pegging. So we assume that a sidechain is UTXO. So it's well, Ergo-like extended UTXO. Blockchain, we assume that it has Ergo tree support, so most of Ergo blockchain Ergo tree features, but sidechain also could support more, for example, zero knowledge primitives and so on. Well, we assume that main chain state is provided by consensus, so sidechain validators should be at least SPV validators of the main chain, which is well, practical, realistic assumption after all. And we assume that there is no storage rent on a sidechain, which is okay, as sidechain bloat is not so critical issue probably, and absence of storage rent on sidechain would allow to simplify contracts a lot. So we are skipping consensus details as they could vary, but there are some options we may think about. So, well, there could be merged mining when some main chain miners also mine sidechain in parallel, and we will consider some details, some possible merged mining scenario further. Or we can think about delegated proof of stake or some big federation, maybe not even big, running sidechain, and we can then have consensus validation on the main chain even, as Spectrum did validation of 1024 signatures batch on Ergo recently, for example. And well, we need for sidechain consensus to deliver a verifiable proof of sidechain state on Ergo, and well, in both cases at least this is possible, but there could be also other options for sidechain consensus. Alright, and then well, we are this verifiable on the main chain consensus. Sidechain validators are going to deliver sidechain state on the blockchain, which is, in the simplest case, is just a quadruple of 4 values, for which evolution is happening. Well, in this quadruple, the first value H is a sidechain height. TH is well, about state changes, commitment to it done in a sidechain block at height H. UH is a digest of Evil plus 3 built on top of UTXO set after processing the transactions in the sidechain block. Well, CH is previous sidechain history, so it's basically a root of Evil plus 3, which contains all the previous sidechain states. Alright, and then this quadruple can be just written in a box with well, special NFT used to market. And well, it's very straightforward then to build merged mining, as well, it's similar how merged mining done for Bitcoin. So for blockchains which are doing merged mining with Bitcoin, for example, Namecoin. So they have a bit similar commitments, but in our case, sidechain state, merged mine sidechain state is also contracts friendly. Well, for these sidechain states, we can have requirements in this GWT contract that sidechain data can be updated only by Ergo block miner. Then, an Ergo miner can mine virtually sidechain by just doing Ergo proof of work and also doing sidechain validation and updating sidechain state box with new data. We are calling this virtual matched mining. So in this case, a miner is just mining the Ergo blockchain and updating sidechain state on the way. And similarly to BIP 301, there could be also blind matched mining variant, where miner is actually not validating sidechain even, but receiving proofs from users paying miner for publishing sidechain data. And users are getting paid with sidechain transaction fees. So in this case we can talk about blind virtual matched mining. Alright, so with sidechain state on the Ergo blockchain, we can do contracts now, which are using these sidechain states to implement trustless two-way PEG. And the PEG workflow is like following. So to get ERGs on sidechain, user first locks them on the main chain with a special contract, and then user claims sidechain ERGs or as ERG. We are calling this token in our example on the sidechain, and as ERGs are available after enough main chain confirmations. And when the user wants ERGs back, he locks as ERG on the sidechain and getting locked ERGs back. Again after enough sidechain confirmations. So then we need for two contracts for two-way pegging. Let's say two set of contracts. So we need for main chain contract and sidechain contract with some additional contracts. Let's revise sidechains assumptions. So again, it's you take main chain state is known to sidechain validators, so to sidechain consensus, and no storage rent, and we also assume that main chain state is available to contracts on the sidechain. In our project, we consider simplest case when main chain state is available via special context extension variable, which is doable with minimum modification to Ergo tree interpreter and actually to the Ergo node code. So then the current code can be forked pretty trivially in order to launch a sidechain. Alright, then let's consider main chain contract. So the main contract on the Ergo blockchain, on the main chain, is unlock contract, and user sends his ergs to this contract to then get them back on proceeding with unlock. So unlock happens in 2 stages, right? But yeah, let's consider the workflow first, right? So user locks ergs on the main chain by sending them to this contract, so by creating a UTXO with this unlock contract, right? And when it comes back to the main chain on the 3rd step, the contract is unlocking ergs on getting a proof that SERGs are locked on the sidechain properly. So that unlock contract is working in 2 stages. First, user submits sidechain state as a data input, read-only input, along with sidechain box ID and proof of its inclusion into sidechain UTXO set. After enough sidechain confirmations, user submits sidechain state with proof of inclusion of the same box again. And now also the user submits contents of the sidechain box, and the contract, the unlock contract, checks that the box is locking enough as ergs, and that the box is non-spendable, so it has a false contract. Also, there is need for protection against double claims. So there is also a need for proof that the sidechain box was not claimed on the main chain before, and for that we have a special helper contract with registry of previously claimed boxes. Alright, and on sidechain we have 2 unlock contracts actually. So it's a little bit asymmetric design. So we have unlock stats contract, which is creating a box with SERGs protected by the second unlock complete contract on presented proof of inclusion of a main chain box protected by main chain unlock contract into main chain UTXO set. And after enough main chain blocks passed, the unlock complete contract can unlock SERG tokens. If the main chain box is still in the main chain UTXO set, so we need for proof of that unlock complete contracts is checking that. Alright, so well, here high-level details, and you can find complete code in the repository. And well, let's jump on conclusions for this pretty small but I hope significant ErgoHack project. So there are some things missed, such as tests. So there is a need for, well, auditing contracts for possible weaknesses and, well, fixing them. So, for example, sidechain state is being refreshed every block, so it's not friendly to use it in contracts at all. But there are certain ways to bypass this issue. And well, at some point contracts in the repository will be updated towards that. And then yeah, it's worth to launch a sidechain, a real sidechain, to play with it. And well, despite the absence of well, tests and really working sidechain, it's already quite clear that with cheap eval +3 success from contracts, it's possible to do trustless pegging indeed, and it's feasible. It's not that expensive to run contracts provided, so they're not that heavy even. And thus security of a sidechain, of an Ergo sidechain, could be reduced to security of its consensus mechanism, which is a great improvement in comparison with sidechains we have today, which are usually on federated pegging. That's all. Thank you for your attention, and if you are willing to chat about that, please reach the main Telegram group, or even better, developers Telegram group. You can find it in the main one. And well, we appreciating contributions. So if you are willing to contribute in Ergo sidechains, well, welcome, and let's discuss that. That's all. Thank you for your attention. Have a great ErgoSummit. Bye.